Hello everyone. So in this lecture, I'll be making the AIs actually come close to me and form a circle around me using EQS. Okay, and also I'll be fixing a bug that was left behind in the last lecture. Okay, again, so sorry about that. So I'll fix that, and also finally, what I'll be doing is changing the base of this project to C++. Now, the reason having a base in C++ is because some functionalities are better suited for C++, and I will explain everything that I do, and knowledge of C++ is not necessary to follow along my tutorials. Okay, I'll explain everything what I'm doing and equivalent of what it would be in blueprints. Okay, if I mean as much as it's possible. I mean, not everything is possible in blueprints. So, but I will explain everything. Okay, so okay, let's get started. Let's start with the bug fix. So the first bug is when I am playing, I go attack the enemy. As you can see, since they are moving, they actually it actually goes into the wrong place and wrong direction sometimes because they are moving and they don't stop when they are being attacked. Yeah, so that's a thing. So let's go ahead and um, first we'll open up the grunt. Okay, and also the player as well. So over here we set the current enemy, and over here we want to tell the enemy that you need to stop, right? You can tell the enemy over here, which is a good enough place, or where else? Let's see. You also have our set current enemy over here. Yeah, we can do it over here as well. And in the grunt we have the enemy component, and over here we only get the head direction, so that is way late, right? So not the place, so probably over here, right? Get current enemy. So now the function will be over here in the enemy component, so we'll create a function, and this will be stop enemy logic. And this will be a boolean stop. This will be control enemy logic stop, and if it's in the enemy grunt, we have the controller as the detour controller base, right? So over there we are setting the behavior tree. So we can get the owner, we can get AI controller, and from here we can get the brain component. So component is basically responsible for all the behaviors that run in the behavior tree. Okay, so yeah, basically we want to say the stop logic for the behavior tree, and the reason is being attacked. Okay, so stop logic, that is fine, and if false, then we can restart logic. No, we don't want to restart logic. We want to start the logic again back up. So I think is paused. So yeah, there is valid. So now again in the display over here, we want to check get component by class. Now this is the AC enemy component. We need to make sure is valid, like the enemy has this component. If they do, then we want to control enemy logic, right? And this is stop over here. And once the head direction has play hit montage has been played on completed and on blend out uninterrupted, I want the stop to stop again. So now if I play, they see me, they stop over there in their place, so that actually helps a lot, as you can see. And also it becomes red, that means it's stopping the brain component stops, and then it starts back up. Now that solves first that's also first issue. Now the second issue is not the issue. The second thing that we want to do is make them choose a place near us, and I'll implement the AI director in our next lecture. So, and obviously that would help us to actually find which place or how many players are actually moving towards how many enemies are moving towards the player at one given time, right? We don't want all of them to run towards them, right? Wouldn't look good. So like only 2 or 3 moves near him, and then one of them actually attacks him, attacks the player, um, right? So that is much logical gameplay wise. So that's how we would do. But for now, let's go ahead and see how EQS is made and how it runs and everything in this lecture. Okay. So for that, let's go ahead to our blueprints. Blueprint folder, AI. We'll create a new folder, and over here we'll call this EQS. I'll create my first EQS over here and call this find empty place near player. Okay, or not near, around player. Around player. Now I also want to add a testing pawn, and this is an EQS testing pawn. So from the blueprint class, type in for testing pawn, and you will see EQS testing pawn. Now dp underscore EQS t underscore pawn. Now inside this EQS, we have we have the actor of class, so it will generate set of actors of actor around query. So basically it searches for the actor class and it creates actors in radius. We don't need this. What we need is basically A circle, it would just be a circle. A donut is better, right? So basically a multi-layered circle, right? So inner radius will be, let's say, 500, and this one can be up to 2000. Okay, so yeah, and let's see how that looks using the testing font. So if I drag and drop over here in the details panel, scroll down and you will see the EQS. We have the query template, and as you can see, this is how it would look if I had that range. So 500 max 1000 is fine, I would say. Perhaps, yes, looks good, right? Near the player. Now you can make this higher, but higher means more points. More points mean lower performance. Yeah. So you will have to make sure that you don't do excessive amounts. Do whatever is actually needed. Okay. So that's one thing. Another is the center. Center is done using a context query. So you need to create that, and inside EQS I will create a new folder, and this will be text. Again, go to blueprint class. We will have the environmental query context blueprint base. So I'll select that. I'll call it environmental query QC query context, and add the BP in front, signifying it's a blueprint. And this one will be find not find, this is basically target player. Okay, so from here, if you open up, you can see you have a you can override 4 functions, 4 of them being actor set. So it will return a set of actors as query. Okay, so we don't need that now. We can also return a location set, again a set of locations, we don't need that. And then is the single actor. This is what we need because the target actor, so we need this one. And then there's the single location, basically just one vector location. So we just need the actor for now. And the way is, so it actually receives a courier actor and a courier object, right? So the courier actor, if you are actually running from a behavior tree, right? So we already have the behavior tree, and over here, if you are using run EQS directly, right, like this, the courier by default is the actor that's running this behavior tree or running this EQS itself. So this would actually be our AI. Okay, now how do you know this for sure, or how do I know this for sure? Like, obviously, just don't believe anything anybody says, right? So let's print this string out, right? So over here, actor. Now obviously you also need to return an actor over there, otherwise it will give you an error. So let's go ahead and test it. Now if you go to the output log, oh right, I did not even choose it to begin with. Right, as the center. Now let's change it to the target player. Okay, yeah, there we go, target player. And in the output log below, you can see courier actor is BP Grunt, whoever is running it basically. So that's how you know that the courier actor, if you run it from the behavior tree, will always return the actor who's running the behavior tree. Okay, so from here now we know, or we can actually get the blackboard, right? And we can get value as an object. Okay, now I can make a literal name of it, and that would be our target actor. Okay, so now we have to make sure it's a valid one, and if it is, now I cannot actually just um, plug in an object actor to actor object reference, right? So I basically have to cast, and since I know this will always be a character class, I can definitely just make it a pure cast of character and then return it, right? So with that being done and generating a donut over there, what I can do is I can turn him around and check for myself. I can press the debugger, that is the apostrophe key. Okay, and then you can press the 3 on the numpad to see that the EQS is being created. Now it is creating one at that corner, right? So now if I play again, you will see that it generates the same one over there. Now why is that? Because in the behavior tree run EQS, first of all it's returning a self actor, which we should actually be saying the target actor and then move to that location. That's fine, but I mean it will find an answer either way, whether you set that answer or to some location and then move to or not, it doesn't matter, right? The reason being, it was actually taking the single best item. Now from there I can actually do a single random item from the base 25, and that way each time I do, now this would be a random place, as you can see, right? Now obviously, again going back, it would be better if I don't actually have a move to, so I can actually see that it chooses a random location. See, that was the winner. Now this is the win, so it's a random chance, right, from the best 25%. Now if I come up here, okay, sorry, not here, in the EQS itself, you can add a few tastes to the donut that we are using. Basically, these are called generators, as you can see over here. So this is a donut generator. In these generators we can actually add a test, some of them being distance, dot product, gameplay tags, overlap, pathfinding batch, project, trace, and volume. Okay, so I want to actually test for a few things, the first being the distance. Now I want the distance between the EQS and the player to be within a certain range. Okay, the range being, like I said, it should be at least 300, and for the max, yeah, let's make it a range. The maximum it can be is 1500. Okay, and now you will see it says prefers greater, right? So obviously I don't want that greater distance, so what I can do is I can get the scoring factor and I can inverse it out. That means now my character will prefer whichever place is the closest to me, like this one. And then again, if I'm to do again, so see, that is the closest. So whatever is the closest one, right, he will prefer that one. And also make it 300, so it's a bit close by. Yeah, something like that. So yeah, looks better. And then I also want to do a test that the path exists from Queria, basically from itself. Okay, the path should exist, and then we'll also want to do an overlap, that is like, is there another pawn standing over there or not, right? We want to check that, and we want to do a inverse of the bull match, means there shouldn't be one over there, right? So only then they can move to that place. So now I'll just add it back in. Okay, so this way we can see how they react. Now since I'll just move it like that, and I'll move this over here on this side. Okay, now if I play, you can see the enemies actually take up a place randomly, and now obviously I don't want them to move around all the time, so I want to add a wait of 10 seconds, okay, for now, because there's no better logic at the moment. And as you can see, yeah, they actually choose random places around me to walk around. Now there's one issue, that they do not actually like check for collision within themselves while moving in, and that's why like they are way too close by. So what I want to do is go to the character movement, and if you scroll down, you'll come under avoidance, character movement avoidance. I want to use the RVO avoidance, and avoidance group, I want them to be 0, have a avoidance weight of 0.5, and groups to ignore themselves, and group 1. And I'll also go to the player itself, search for avoidance. Now obviously I want this to be 0.2, and I'll be group 1, and groups to ignore would be group 0. I don't want to avoid the AIs, I just actually, yeah, groups to avoid is 1, sorry. it, AI should not actually ignore any group, okay? So make sure you uncheck these two back. That was a mistake on my part. And also I'm group 1 and they are group 0. Okay, that is fine. 500, and they maintain a better distance. So I'm gonna test this one out really quick. Okay, so much better. Yeah, so yeah, this is a lot better, okay, from what we had in our last lecture. And okay guys, so for the last part, we'll be changing the base project to C++. Okay, so for that, go to the tools and new C++ class. Okay, I will actually add normal object class. Okay, and this one will be ffcs underscore data. So I'll actually have all the data such as enums and structures changed to C++, okay, because I prefer them being in one place and easier to read. Um, so yeah, I'll just have it over there without uh, different issues. Also, yeah, data structures and enums actually cause pose some issues actually, which is I mean, you can solve it. It's just annoying to have them like fix them every time you change something. Okay, so once that is done, close this. Save selected. I'll go to the folder and delete the vs, sln, and .vs config. These three files. Okay, the first time round, I'll actually regenerate them. Regenerate Visual Studio project files. And once that is done, now I'll open up the SLN. Okay, and now it's loading. So yeah, I'll just let it load. Now you might be using Visual Studios by default. Okay, I'm using Rider. It's a paid IDE, so uh, follow along with Visual Studio if you have any questions. I mean, there are some things such as, debug, run, those would be different, but more or less it's the same thing, same logic, everything. Okay, if you have any issues, reach out to me on my Discord server. Okay, go into the help channel and ask for help if you are having issues uh, using the different IDE. Okay, and I will try to help you as much as I can. Okay, so now it has loaded in once, so now I will actually build the solution for it. And the first time it can be a bit time consuming to run this. Okay, build this. So I'll just pause it over here. Okay, and get back once it finishes. Okay, so this one, yeah, it actually creates this folder, so just delete that if it did the same for you. And yeah, other than that, I think it's good. I'll build this once again. And the below two errors were Unreal Engine errors, so ignore them. I mean, they pop up every time you try to build, but if you try to run or debug in Visual Studio, it should be just fine. Okay, yeah, like I said, these two will stay, so just go ahead and run, and it should build. It has succeeded without any issue, as you can see. Okay, wait, why did it run a debug game? Sorry. Also, yeah, the target should be editor. If you're using Rider as myself, make sure you have configuration as debug, target is editor, and Windows 64. Okay, so let me run this one once again, and it should open up without any issues. Okay, so the build has finally succeeded and it's loading up the editor. Okay, so yeah, everything seems fine. And yeah, we have a C++ project now instead of a blueprint one. So yeah, the video is getting actually a bit longer than I wanted it to be, so I'll actually continue from my next lecture. Okay, so thank you guys, and as always, if you want to support me and the work that I'm doing, you can subscribe to my Patreon. It starts from just $1 a month. Okay, and also there are different tiers based on the needs of different people. Okay, so do check it out once. Thank you.